This worked example shows you how to solve equations that require you to take roots of a variable. So first we're going to look at this equation right here, and we're going to pick out exactly what we need to do here. And this is like any other equation. If this were just x, you would try to isolate the x. It's not x, it's x to the 8th. But if I were trying to isolate it, I would get rid of this minus 25 by adding 25 to both sides. When I add the 25 to the left, that goes away. When I add it to the right, I'm going to get obviously a plus 15 here. Now, how do I undo x to the 8th? Well, if this was x squared, you would just take the square root. Remember that taking the root is the opposite of an exponent. If this is the same, then that obviously equals x. Same thing with x cubed. If I took the cube root, that would be equal to x. So we understand how this works. How I undo this now is I'm going to have to take the 8th root, as he would say. I'm sorry, let me fix that. I'd have to take the 8th root of x to the 8th, because that would give me x down here, and that's how I'm going to try to isolate it all by itself. But to do that, I have to also do to the right side of the equation whatever I did to the left. So if I take the 8th root of 15, well, that's going to be a little bit interesting. You need your calculator there, okay? But when you punch in 15 to the 1/8 power in your calculator, or 15 caret parentheses 1 divided by 8, it should kick out a number. If you've got a y to the x button on your calculator, you could punch in 15 to the parentheses 1/8 power. This is why we studied rational exponents. But either way, the 8th root of 15, or the number when you multiply it by itself 8 times, is 1.40. So this equation works out, and I have to say plus or minus because it's an even root. Whenever you take the square root of something, you got to go plus or minus. Okay, if it's the cube root, you don't have to, because that will actually come out as positive or negative, whatever the sign underneath is. Okay, we can talk more about that later, but your answers to this one are plus or minus 1.4. Okay, hope that helps there. Let's do another one. All right, here's one. X minus 4 to the 4th equals 81. So nothing to do yet. I have to get rid of the exponent first before I can work the parentheses. So right off the bat, I'm going to take the 4th root of x minus 4 to the 4th. Don't let the parentheses confuse you. Remember, if we had x to the 4th and you took the 4th root, that would be equal to x. Well, in this case, just happens to be x minus 4 to the 4th. Don't FOIL it out. Don't worry about that. Just take the 4th root, and what should come out, just like up here, what comes out is just x minus 4. Now, if I take the 4th root of 81, maybe there's something inside of there that is a perfect power of 4. I know 81 is 9 times 9, but 9 is really 3 times 3, so this 9 is 3 times 3. Guess what? That's 81. I have 4 3's in there, or 3 times 3 times 3 times 3, or actually I could rewrite this as 3 to the 4th. And of course, the 4th root of 3 to the 4th is simply, well, 3, right? Anything to the 4th power, if I take the 4th root of it, it undoes the exponent to the 4th power, so that works out well. Now, again, it's an even exponent, so what I have to do is I have to make sure I take plus or minus 3. Okay, because if I put a minus 3 in there, minus 3 times minus 3 is 9. Minus 3 times minus 3 again is 9. 9 times 9 is 81. So minus 3 is also a 4th root of 81. Okay, what is remaining on the left side of this equation is still x minus 4. Do the simple math, add 4 to each side, and now I'm going to get plus 4 plus or minus 3. So just like with square root problems that were not as complicated, I get two answers. Plus 4 plus 3, which is 7. And I also get plus 4 minus 3, which is 1. So x can be 7 or 1 in this case. Is that confusing? Let's check it. Let's plug in a 7. 7 minus 4 is 3. 3 to the 4th is 81. Yeah, it works. What about 1 minus 4? Oh, that's a minus 3. Minus 3 to the 4th. Punch it in your calculator if you want. Minus 3 squared is 9. And if I have minus 3 squared times minus 3 squared, that's 9. And that's 9. 9 times 9 is 81. Minus 1 also works for x. I'm sorry, 1 minus 4, which gives me the minus 3 value. 1 also works. So both of these answers have been proved to work for this equation. So be careful when you take the root of something and it's an even root, you must put the plus or minus there. I should have put it here too, but there you go.